11 kilometers beneath the surface of the Pacific Ocean, there's a place where the water pressure is over 1,000 times what you feel right now, where the temperature hovers just above freezing, where sunlight has never once touched the seafloor. It's called the Mariana Trench, and it's the deepest place on Earth, deeper than Everest is tall. For most of history, we assumed nothing large could survive down here. But what if the ocean's most infamous predator, a shark twice the size of a school bus, extinct for over 3 million years, never actually left? What if Megalodon didn't go extinct? It just went deep. Before we dive into the deep end of this theory, let's be clear about what we're doing here. This is speculative science. A what if built on real biology, real geology, and real fossil evidence. Megalodon, or Otodus megalodon, is one of the most fearsome predators to ever exist. And its extinction around 3.6 million years ago is one of paleontology's most debated mysteries. Some of that debate centers on a tantalizing possibility that the fossil record showing Megalodon disappearing from shallow coastal seas doesn't necessarily prove it disappeared everywhere. So today, we're asking the big question. If a population of megalodons had retreated instead of died out, sinking into the crushing dark of the Mariana Trench, could they have survived? And if they did, what would that mean for the rest of the ocean and for us? To understand whether Megalodon could live in the trench, we first need to understand what kind of animal it actually was. Megalodon ruled the oceans for roughly 20 million years, from about 23 million years ago, until its disappearance. Fossil evidence, mostly gigantic serrated teeth the size of a human hand, suggests it grew somewhere between 15 and 20 meters long, rivaling the size of a sperm whale. Its bite force estimates exceed anything alive today, including modern great whites and even crocodiles. But here's the detail that matters most for our trench theory. Megalodon likely wasn't like an angry white shark, a cold water animal by default. Evidence suggests it was a regional endotherm, meaning it could generate and retain some of its own body heat. Similar to modern great white sharks and mako sharks, that let it patrol a huge range of temperate and warm coastal waters. Everywhere, from nursery grounds in shallow bays to open ocean hunting grounds. It fed on whales, large fish, and other marine mammals, using warm, prey-rich, shallow to mid-depth seas as its hunting territory. In other words, Megalodon was built to dominate the sunlit and twilight zones of the ocean, not the abyss. So why did Megalodon vanish? The leading theory is a perfect storm of environmental change. Around 3.6 million years ago, global sea levels dropped and ocean temperatures cooled sharply as the planet slid toward the ice ages. many of Megalodon's shallow coastal nursery habitats shrank or disappeared. At the same time, its prey was changing. Baleen whales were evolving to be faster and to migrate toward colder polar waters, where Megalodon, as a warmth-dependent predator, likely struggled to follow efficiently. And a new competitor was rising fast, the great white shark, along with early killer whales. Both faster, more agile hunters that could outcompete a slower, bulkier predator for the remaining food. Faced with a shrinking habitat, vanishing prey, and new rivals, the traditional story is simple. Megalodon starved into extinction. But our what if asks a different question. What if some of them didn't fight for the shrinking coastline? What if they fled downward instead? Into the one place large competitors couldn't easily follow? Let's actually go there. The Mariana Trench sits in the western Pacific, near the island of Guam, stretching for over 2,500 kilometers. Its deepest point, the Challenger Deep, plunges to nearly 10,935 meters. So deep that if you dropped Mount Everest into it, its peak would still sit over 2 kilometers underwater. The pressure at that depth is crushing. More than 1,000 times what we experience at sea level. Enough to instantly implode almost anything not specifically engineered to withstand it. Sunlight doesn't reach anywhere close to these depths. Total darkness begins around 1,000 meters down and never lets up. Temperatures hover just a few degrees above freezing, except near scattered hydrothermal vents, where superheated, mineral-rich water blasts out of the seafloor and creates strange pockets of warmth and life in an otherwise hostile world. It's an alien landscape, and yet it's not empty. The trench isn't lifeless. It's just built differently. Scientists have found amphipods, strange shrimp-like creatures, thriving even at the very bottom of Challenger Deep, higher up in the twilight and midnight zones. We find genuine deep-sea giants, giant squid, colossal squid, and 6-gill sharks that can grow over 5 meters long and are perfectly adapted to cold, crushing, lightless water. These animals share a few key traits. They tend to move slowly to conserve energy. Since food is scarce and calories are precious, many rely on ammonia-rich tissue or pressure-resistant cell structures. Instead of dense bone and muscle built for speed, and almost none of them are warm-blooded. Because generating body heat in near-freezing water is a massive energy cost that the food supply down there simply can't support. This is the environment our hypothetical trench megalodon would have to fit into. And immediately, we hit our first major problem. Remember, Megalodon likely relied on regional endothermy, generating internal heat to power fast, aggressive hunting in temperate and warm water. That's a huge evolutionary advantage in a sunlit bay chasing a whale. In the trench, it becomes a liability. Sustaining body heat in 1 to 4 degree water for an animal that size would require enormous amounts of food energy. Food that simply doesn't exist in the volumes needed at those depths. Then there's pressure. Megalodon's cartilage skeleton, like all sharks, is more pressure tolerant than bone, which is a point in its favor. But its entire body, gill structure, circulatory system, even the buoyancy oil-rich liver sharks depend on, evolved for shallower, warmer water. Deep-sea specialists like the six-gill shark evolved slowly over millions of years, gathering biochemical adaptations for pressure and cold as they went. Megalodon would have needed a similarly gradual, multi-million-year adaptation process, not a sudden retreat over a few generations. So for our what-if to work, we can't imagine one desperate migration. We have to imagine a slow-motion evolutionary bottleneck. A small population pushed deeper over hundreds of thousands of years. As coastal waters became unlivable, adapting incrementally the entire way down. Even if Megalodon's body could somehow adapt, it would run straight into its next problem: food. An adult Megalodon likely needed to eat hundreds of kilograms of meat regularly to sustain a 50 to 70-ton body. Whale blubber, large fish, dense, calorie-rich prey. The Hadal zone of the Mariana Trench has almost none of that. Life down there survives mostly on marine snow, the slow drift of organic particles falling from the surface, supplemented by chemosynthetic bacteria near hydrothermal vents that convert chemicals, not sunlight, into energy. That supports small, slow-moving specialists like amphipods and cusk eels. Not a 15-meter apex predator with a whale-sized appetite. The math simply doesn't work. The trench's ecosystem couldn't calorically support even one adult megalodon, let alone a breeding population large enough to survive for over 3 million years. For our theory to survive contact with reality, we'd need Megalodon to shrink dramatically in size, slow its metabolism drastically, and feed on something we haven't even discovered yet in the deepest, least explored parts of our planet. And less than 20% of the ocean floor has ever been mapped in detail. It's a stretch, but it's not a mathematically impossible one. So let's paint the picture properly. A trench-adapted megalodon, after millions of years of hypothetical adaptation, probably wouldn't look like the sleek, warm water predator from the fossil record anymore. It would likely be smaller, maybe half its ancestral length. To reduce its caloric needs, its skin might pale or lose pigment entirely. Like many deep-sea animals that no longer need camouflage from sunlight, its eyes could shrink, or alternatively, grow larger and more sensitive to detect the faint bioluminescent flickers of prey in total darkness. It would move slower, conserving energy between rare, opportunistic hunts, rather than the fast, aggressive ambush style of its ancestor. In short, to survive down there, it would have to stop being Megalodon in almost every way that made Megalodon famous. It would become something new. Something adapted. Something that traded raw power for patience. Let's put this in perspective one more time. The ancestral Megalodon that ruled coastal waters 20 million years ago stretched close to 18 meters, nearly the length of a bowling lane. Our hypothetical trench-adapted descendant, shrunken by the harsh economics of deep-sea survival, might be closer to 8 or 9 meters, still nearly double the length of a modern great white shark, and still an absolute giant by deep-sea standards. Even scaled down, it would remain one of the largest predators ever to exist in that part of the ocean. Deep-sea adapted or not, it's worth being straight with you. The overwhelming consensus among paleontologists is that Megalodon is genuinely extinct. Full stop. The fossil record shows its disappearance lines up precisely with the ecological collapse we described earlier. And there's no physical evidence, no teeth, no bones, no trace of Megalodon anywhere in trench sediment or deep-sea samples ever collected. Modern sonar, submersible expeditions, and deep-sea cameras have mapped and explored significant portions of the Mariana Trench without a single hint of a surviving giant shark population. This video is a scientific thought experiment, not a claim that Megalodon is hiding down there today. And maybe that's the most fascinating part of this whole thought experiment. Not whether Megalodon survived, but how much of our own planet we still haven't seen. Less than a fifth of the ocean floor has ever been mapped in real detail. There's more unexplored territory beneath the waves near our own coastlines than on the surface of Mars. So the real question isn't just what if Megalodon survived? It's what else might still be down there.